welcome to Mass Expert Video Tutorials, and today we are bringing you about your first video under the course Calculus 2 or Integral Calculus. You know that Calculus 1 deal with what? Differential calculus, and this deal with what? Integral calculus. And you know what? This is Calculus 2, so in case that you are forgetting your Calculus 1, make sure you go back and revise because you really need it here. And if God not be on your side, I may not be taking you through the differentiation in it. I'll just quote you the answer and go my way. Alright, so that is that. We are going to begin with indefinite integral, then we go to definite integral, and we start deriving some of the integral identities and all that. Okay, so without wasting my time, we know that in Calculus 1, differentiation always go in hand with what? Slope. A slope. When you are finding a slope, you say a slope is equal to what? Changing y2 minus what? y1 over s2 minus what? s1. So this is what? Change in y over the change in what? X. And that gives what? dy dx. Okay? So we are done with this concept in Calculus 1, and you know that all that we do in Calculus 1 is all about what? Finding what? The slope. Finding a slope of what? A given what? Function. Now, welcome to Calculus 2. And in Calculus 2, all that we do in Calculus 2 is what? Finding what? Area. It's all about what? Finding area, but here just that it's going to deal with what? Functions. Alright. So, anytime we are in integration, know that we are talking about what? Area. Alright, so indefinite integral. Given a function f of s on some interval I, capital F, this is different from this. Capital F is called an antiderivative. Capital F is called an anti-what? Derivative. If f prime, and you know in Calculus 1 that when we write y prime, f prime, we are talking of what? Dy dx, which is the same as what? Differentiation. Very good. So here, we are saying that f is called an antiderivative. So f can be called an antiderivative if we can take the derivative of what? This. And when you take the derivative of this, you are going to get what? A function. Alright? Good. And that is what we call area. The capital F is what we call what? An area. So we are saying that if you have an area, let's say we have area, that is a function of s. And when you differentiate this, alright, when you take the derivative of this as respect to x, the result is going to give you what? A function. The result is going to give you what? A function. Alright? Because of time, I may want to take you through some things, but get this one for me that whenever you take a derivative, in fact you know it from Calculus 1, so I don't want to go there. Whenever you take a derivative, when you take a derivative, it means that you are taking it, you are taking an area of what? A function, a derivative of an area of a function, and when you do that, you are going to get what? The function of what? The area back. Alright, good. So that is that for such concept. So this A of x is the same as capital F of s. Alright, so we are going to use this example to explain further with what we have here and indefinite what? Integral. So I will show you how to take integration, but this is how you do it. You add 1 here, and whatever you get here, divide by it. So when you integrate this small you are going to get what? The capital what? F of S. Because we are saying that when you take integration is the same as what? Area. So the result of an integration gives you an what? Area. And that area is capital of what? F. And it's called an anti-what? Derivative. So this is going to give you S to the power 3 over 3. Alright. Now, I would like us to add something to it, but let's wait for a while. Now here, or you let me bring it. Let's do it. Because I would like to add another example that will project it well. Okay, so now I would like us to take the derivative of both sides. Because we are saying that when you take the derivative of the area, the capital F, is going to give you what? The function back. So let's see if that theorem is true under indefinite integral of this capital F. And when you take the derivative of this, very good. So when you differentiate this capital F, you are going to get the small one F. Or when you integrate what? The area function, you get the what? The function back. Now let's see if that is true. How do you take derivative? You subtract 1 from the power, alright? Bear in mind that this is the same as what? 1 over 3 s to the power 3. So you multiply the power by what? The coefficient, and you get what? 1. And subtract 1 from the power. Multiply the power by the coefficient, you get 1. And subtract 1 from the power, you get what? S squared. Very good. So now, how will I see what we are getting? That means that if you have a function, watch. If you have a function, and that function is what? S squared. And when you integrate, you get this. Alright? But when you differentiate the results, you are going to get the function what? Back again. And that is what this is telling you. And that is exactly what this is what? Telling you. But I would like us to solve one more example and see what that one we are going to get for that. Example 2. I hope this is clear. The projection is clear. Alright, so first of all, we integrated it and now we differentiate both sides and we have the function back. Is that true for all the functions? Let's see. Let's try on 2s squared plus 3. So we have f of s to be equal to this. So first of all, let's integrate. So f of s is equal to 2s squared plus 3. Now, when you integrate this, that means that you are going to get a capital F of s, alright? And when you integrate this, how do you take integration? Add 1 to the power. You add 1 to the power. Remember 2 is here. You add 1 to the power, you get 3. And now you divide both sides, you divide it by what? 3, not both sides. Add 1 to the power, you get 2 plus 1, you get 3. The results, divide by 8. Plus, now, anytime when you integrate 3s, what will you get? When you integrate 3s, you are going to get what? 3x. You add s to it. We will think about that, but I just want to project you something. Now, either we are going to, what we are going to do here is the same as what we did here. So now, let's integrate both sides. Sorry, let's differentiate both sides. So when we differentiate this, as respect to s, then we differentiate this. Then we differentiate this. So it's going to give you in differentiation what kind of power by the coefficient. So 2s, subtract 1 from it, you get 2 plus When you differentiate this, you get 3. Beautiful, 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 beautiful. I hope you can see what you are getting here. Alright, alright, alright. But here, truly, we have the function back, and that is what? 2f squared plus what? 3. So this is what? Small f x. I hope you can see that. Very good. Now, we are saying that anytime you take integration, and you know it already from your previous knowledge that anytime we take integration, we add plus c to it. Anytime we take integration, we add plus c to it. Anytime we take integration, we add plus c to it. Why do we add the plus c? So, like this, after this integration, we should have add plus c to it. Alright? And what this means is that it's representing the family of what? Constants. So here, after this integration, we should have add what? Plus c to it. And what this means is that it's representing what? Families of what? Constant. Family of constant. So it will still give you the same result, because when you come to this side and you are taking the derivative of both sides, when you differentiate this, you get this. But when you differentiate a constant, you get what? 0. Alright? When you differentiate a constant, you get 0. And yet it will be the same thing, because when you integrate a constant, you get what? 0. So it don't add up, but we just apply to it that anytime, but that only works in indefinite integral. That after every integration, add plus c to it, and the c, this c, right? This represents the family of constants. This represents the family of constants. Alright, so this or that we want to project you that whenever you have a function to rest and you integrate it, you get this. Alright, so that process is called anti-what? Derivative, because when you take the derivative of the integral function, it gives you the function what? Back. So this process is also called integration. So the process of anti-derivative is also called integration. That's why normally people say that integration is a reverse process of what? Differentiation. Alright, so when you differentiate an area or an area function, you're going to get a function back. And when you integrate it, you get a function plus. But this constant, this is a constant. This is a constant. This is a constant. And that represents family of what? Constants. And that represents family of constants. Very good. So now, let's go straight away on what we are up to. So I'm going to give you the basic integration table. The basic integration table. The basic integration table. Okay. So the basic integration table. Alright, so let's look at basic integration table. basic integration table. So with the basic integration table, straightforward, let's go. 1. If you differentiate x in differentiation, what will you get? 1. So what we are saying is that since integration is a reverse process of differentiation, then when you integrate this constant as respect to x, you are going to get this back, and that is what? S. If you have a polynomial function in differentiation, as to the power n, and when you differentiate this, you are saying that you multiply the power by the coefficient, then you subtract 1 from the what? From the power. But please remember that in integration, you add plus c to represent family of what? Constants. Alright. And here too, when you integrate a polynomial as to the power n, when you integrate a polynomial in differentiation, in integration, what we do is that you add 1 to the power, then you divide the result, or the whole n plus 1 by 8. Or you add 1 to the power and divide by the what? The result. Then you add plus c. So this is what we do in integration. 3. When you differentiate sine s, what will you get? Cos s. Alright. It's a reverse. It's a reverse. That means that when you integrate cos s here, when you integrate cos s as respect to x, this means that we are integrating as respect to what? X. That means the result should be in terms of x. And you are going to get this result because it's a reverse process. Alright? So when you integrate cos s, you get this function, which is sine x plus c to represent family of constants. 4. Let's go to cos. Now, I'm going to do something. Okay. Cos x. When you differentiate cos x, we know that you're going to get negative sine x. Alright? And since it's a reverse process, that means that when you integrate negative sine s as respect to x, you get this function back, which is what? Cos x. Then you add plus c. But look at it. Integrating negative sine s, you see, you may not be getting integral of negative sine s. So here, let's negate both sides. In fact, the reverse process is true and it's working. That's what I want you to know. So when you integrate this, so you don't need to choose these things, okay? Once you know the one in differentiation, that's why we say that before calculus 2, make sure you revise calculus 1. Because once you know the differentiation, it's just a reverse process, so you go your way. So yes, the reverse process is truly working. When you integrate this, you get this function back. But what I'm saying is that this negative sign here will not help us. So let's negate both sides. So when you negate both sides, this one will go, then this one will be what? Negative. So that means that when you integrate sine s, you are going to get negative what? Cos s. Beautiful. Alright, so let's move on. What about tan? 5. When you differentiate tan s, you get what? Sec squared. Sec square s. Don't forget your differentiation. Sec square x. In the same way, reverse process. When you integrate sec square x as respect to s, you are going to get I hope it's clear. Alright. function back. Beautiful. Then you add plus c to it. In fact, I'm helping you not to be chewing these things. If not, you'll be confusing yourself with the one in what? Differentiation. 6. When you differentiate cot S, we know that when you differentiate cot S, you will get cosec square. When you differentiate cot S, you get cosec square. Sorry, negative cosec square. Very good. Negative cosec square S. Reverse process will work. Negative cosec square S as respect to S. So when you differentiate cot, you get negative cosec square. So when you integrate negative cosec square, you get cot. You get cot S. You get cot S. But since this will not work properly for us, let's negate both sides. So you get negative cot S. Alright. What is left? Sec 7. When you differentiate sec S, you get sec tan S. You get sec S tan S. Beautiful. Reverse process will work. That means that when you integrate sec S tan S as respect to S, you get exactly this, and that is sec S. Alright, and that is sec S plus C. Plus C plus C. Alright. 8. Let's go to cosec. When you differentiate cosec S, you are going to get cosec S cot S. You get negative cosec S cot S. In the same way, when you integrate negative cosec S cot S, it will give you this result, and that is cosec S plus C. Beautiful. I love what I'm deriving. Alright, and when you negate both sides, the negative will come to this side. So please, differentiation is the reverse process of what? Integration. Truly. So please don't forget about your differentiation. If not, you'll be chewing formulas. Alright, very good. So that is that. This is established that whenever you differentiate S, you get what? 1. When you integrate 1, you get S. Just that in integration we add plus C to represent family of what? Constants. Sine gives cos, cos gives sine. You see that? So just know this. When you differentiate cos, you get negative sine. That means that when you integrate sine, you get negative cos. You get negative cos. Tan gives sec square. Integral of this gives tan S. Cos gives negative cosec square. So integral of this gives what? That. Alright, so that is that for that. Now, we have 6 trigonometric what functions? Cos, tan, sine, and 8 what? Reciprocal identities, which is what? Cosec, sec, and cos. Now you can see that we have been able to establish the integral of cos s, integral of sin s, integral of tan s. Sorry, integral of cos s, sin s, integral, no. So you can see that we don't have integral of tan s. We don't have integral of cot s. We don't have integral of cosec s. We don't have such. How you can see that? We don't have such. So does it mean that it's not there? It's there. You establish it when we get there. Alright? But for now, you are allowed. Alright, I'll be back with an example. Alright, so let's look at these examples. Integral of s power 4 dx. When you have to integrate s power 4 as respect to s, what we are saying is that this is a polynomial function. So you just add 1 to the power, so that would be s to the power 5. Or 4 plus 1. Then you divide by 4 plus 1. Then you add plus 6. So this will give you s to the power 5 over 5 plus c. I hope it's clear. Okay. Secondly, we are saying that if you have 1 over, let's try for 1 over s to the power 3 dx. So with this, please, you know in differentiation, I'm on calculus 1, I made you understand that you cannot differentiate something which is not in the form as to the power what? N. It's the same way we are doing here. You cannot integrate a function if it's not in this form. So looking at this function, this is properly in this form because we can see the a to be the coefficient, which is 1. The n is this, so it is properly in this form. But this second question is not well in this form. So to make it well in this form, this is the same as s to the power negative 3 ds. I hope you can see that. Indices, this is the same as this. So now that we can get it in this form, so we can now see the coefficient, which is 1, and the power, which is what? Negative 3. But here you cannot say that the power is what? 3. Thank you for your understanding. So here, straightforward. Add 1 to the power, you get negative 2, and divide by what? Negative 2. Because when you add 1 to negative 2, you get negative 2, then you divide by it. So then you add plus, so the result is finally negative half s negative 2. But even with this, you can still apply something that this power negative 2 will be s squared here. Alright, so don't forget that. Now, what if we have integral of square root of s dx? Having this is still not in the form y is equal to as to the power what? N. So since it's not in that form, then we make it be in that what? Form. Okay? Okay, so we make it be in that form. And that is going to be what? Now, you add 1 to the what? To the power and divide by what? The result. And add plus e to it. So this is going to give you s3 over 2. Then all this over what? 3 over 2. And 3 over 2. When you divide all by 3 over 2, it's the same as 2 over 3 here plus c. Okay. Now, what if we have integral of 1 over s dx? This one still not in that form. Please, it's very, very, very necessary. I would like you to not forget about your differentiation because it's purely working in integration. So here you apply your algebra, negative 2 at ds. I hope you can see that. Oh, sorry, negative 1 ds. Now look at something here. When you add 1 here, and divide by this, what will you get? You see, you get what? This is 0. Alright? And any number raised to the power 0 is what? 1. And this is going to give you what? 0. What is this telling you? What is this telling you? Indeterminate. Because 1 over 0 is what? Undefined. Alright. So, you cannot solve such question by applying that idea, but we need to apply our natural logarithm. So take note that anytime you integrate 1 over s ds, you are going to get ln s plus c. This is not that, but rather this. Alright? Thank you for your understanding. Take note of it. It's very, very necessary. Okay. Let's look at some properties. Properties of integration or indefinite integral. The first property is that whenever you integrate a constant and a function, that means that having, let's say, 2n squared, 2 to the power 3, and those things, alright? When you are integrating as respect to s, what we do is that you can plug out this what constant and integrate what the f of s as respect to what s. Then when you are done, you come and multiply your result by what the constant is also what correct. Secondly, if you have an integral of f of s, let's say we have two functions, plus or minus g of s. As we did in differentiation here, we said that you can differentiate 8 term by 10. In the same way, here too you can integrate this what 10 by 10. You can integrate this what 10 by 10 plus or minus. You can integrate this what 10 by 10. Don't forget that. Alright. Somebody will say, sir, what about products? What about products? Because we have talked of we have talked about addition and what subtraction function. So what about products? Let's see. Is f of x dot this as respect to s the same as integrating this f of s ds times integrating g of s ds. Is that what you are thinking? Is that what you are thinking? Or is integrating this the same as this? Please, no, it's not. This is not equal to this. What this actually means is that no matter what this function is and no matter what this function is, you can expand and simplify it, and when you are done, then you integrate what? Both. And then you integrate each one term. Alright. So for instance, if you have, let's say, s plus 1, s squared plus 1. This represents f of s, this represents g of s. So you can expand and simplify it and take the integration of what? Both sides, and it's going to work for you. Alright. So that's how you do it. Let's try some examples. Okay, so let's look at the integral of 2s ds. Simply, here the power is what? 1. So 2, add 1 to it, add 1 to the power. Then you divide the results by this. So this gives what? Plus c. So this finally we get s squared plus what? C. Alright? Thank you. So that is that for that. Okay. Let's look at this one. Integral of 1 plus x squared dx. Having this, we are saying that we integrate it what? 10 by 10. You integrate it what? 10 by 10. So when you integrate 1, you get what? S. Plus, when you integrate this, you get s to the power 3 over 3 plus c. Okay. Now, let me emphasize on this. We are saying that when you integration, we add classes. So someone may choose to add c here and another c here. But please, let's look at something. If you get s plus c, s to the power 3 over 3 plus c, you add c to c and you're going to get what? 2c. Is that also? But 2c is still what? A constant. So the whole of this is what? A constant. So writing this is the same way as writing it like this. But this is not fair enough. This one is accepted. Alright. So you take the integration and after that you add plus c to the end of it. Okay. Alright again. Okay, let's try on integral 2x to the power 5 plus 3x squared plus minus 3x squared plus 4x minus 8. Integrate this as respect to what? S. So here we integrate it 10 by 10. Okay. So now you can do the 10 by 10 of here. Okay. By not repeating integral of this, integral of this, integral of this again. You know that when you are integrating this, you write this alright. S to the, so you add 1 to this, you get 6 divided by 6 minus. Hope you can see that. 3s, add 1 to this, you get 3 divided by 3 plus 4s, add 1 to it, divided by 8 minus 8 is a constant, so x. Then lastly you add plus what? C. Because even if you repeat plus c plus c plus c plus c plus c, at the end when you add, it's still a constant. Alright, so here you are going to get x to the power 6 1 over 3 minus this will cancel this, so x to the power 3 plus here this is going to this 2 x squared minus 8 s plus c. So this becomes your final answer for that. Alright. Hope you are loving it. Trust you do. So you can pause the video and start solving it. Okay. Integral of s squared minus 2. I'm not establishing the concept. That's why I'm going small like that. We will get to the case where I will be moving fast. So we have here s cubed minus 3 dx. So this is the product that we are talking about. Please don't take integral of this, the results, put it down, integral of this, the results, put it down and come and multiply. Don't do it like that. And don't be thinking that it's a product to you. Hey, I beg you. Alright, so here what we do is that expand and simplify the function and take the integral of it. So here you multiply s squared by x cubed minus 3 minus 2 multiplied by s cubed minus 3 dx. So this to this you get s to the power 5 minus this to this 3x squared, this to this you get 2x cubed, again or 2 3 6 dx. We haven't taken the integration, so keep on repeating it until you take the integration. Once you start taking the integration, then you stop writing the integral sign. So you keep repeating the sign. So s to the power 5 minus this, the simplified form of this. Okay, let's bring minus 2s cubed minus 3x squared plus 6 yes. Now, the final result is going to be, when you integrate, you get x to the power 6 over 6 minus, I hope now you are getting the concept small, the power 4 over 4. And when the concept is stiff, you can now solve it quick. Don't forget to add plus c, because if you don't add that plus c, everything that you have done is what? Wrong. Alright? Make sure you copy it well in case you don't understand anything. Go back and do it again. Alright, so let's look at our next example. Let's look at our next example. So that is integral of cos s over sine squared. Okay, sine square x by this idea. We can rewrite, because this, we know that it is sine square, so we can rewrite this as cos over what? Sine s. And this one is 1 over what? Sine s dx. Having this is the same as having this. You can multiply this by this, you get this, multiply this by this, you get this. Alright. So we know that, but don't forget your trick. Cos s over sine s is equal to what? Cos s. It's not tan s. Tan s is sine over cos. So this is what? Cos. And 1 over sine s will also give you what? Cosec x. Cosec x. Don't forget about that. Cosec x. So that means that here we are going to get, by substitution, we are going to get cos s times what? What is it? Cos s times what? Cosec x. And we are integrating it as respect to what? X. So straightforward. Go back to your basic table of what? Integration. And go and check. What is the integral of cos s cosec x? So here, quickly, then you remind yourself that anytime you differentiate cosec, x, you are going to get negative cos s or negative cosec s cos s. When you differentiate, you get this. That is what? The reverse process. That's what I'm introducing to you. Therefore, what differential equations? Differential equations, like when we have a differential equation, is an equation whereby we have a derivative with it. Alright? Okay. So for instance, looking at this one, you can see that the idea is that can you find the antiderivative, the capital F, such that y is equal to what? That satisfies dy is equal to f of s. All that we are saying is just simple, okay? We are saying that can you find this such that this is equal to this? For instance, having dy dx is equal to f of s. You are saying that, can we get something like y is equal to the antiderivative or the integral function? Here, we can do cross multiplication here, alright? And that is going to give us dy is going to be equal to what? F of s ds. That is by cross multiplication. Then you integrate what? Both sides. And when you integrate both sides, you are going to get y to be equal to. You know that when you integrate this function, you are going to get a capital what? F of s plus what? C. So that is all that we want to establish what? Here. So this is the idea of differential what? Equation. It's all about you what? Taking an antiderivative of the differential equation. Alright, so for instance, let's look at this one. dy ds is equal to 2s to the power 4. So having this, if you want to get a function, okay? So if you want to get a function back, first of all, you know this is over 1, so cross multiply, you get y is equal to what? 2s to the power 4 what? ds. And when you integrate both sides, it means that you are undoing this what? Derivative. Or here is 1, alright? So when you integrate 1 as respect to y, you get y. And when you integrate this, you get 2s to the power 5 over what? 5 plus c. And that is all what we are doing. So this is what we call capital what? F of s, or the area what? Function. So that's the idea I want to give it to you under the derivative. So this is also called a slope what? Function. So if you have a slope function or rate, sometimes you hear rate of change. If rate of change is equal to 2 raised to the power 2s to the power 4, then to get a function, you just go by the idea of a differential equation. That is what? Integrating both sides of it to undo it and get a function what? Back. Alright, let's go to initial value program. Initial value program. Now, this is the same as IBP. You can see that this function that we are having here is in terms of what? C. This is a general solution because the result is in terms of what? C. But sometimes an initial value can be given, whereby after that you go and do the substitution back and you are going to get a particular what? Solution. So, for instance, you are going to be given dy ds to be equal to a function in terms of what? S. Then an initial solution will be given to, let's say, s naught, one plug, you get what? Y naught. So this and this will be what? A value that will be what? Given to you. Let's look at this example. We have dy ds to be equal to 1 over 2s to the power 3. So having this, the initial value is 1 equal to 0. This means that when s is equal to 1, y is equal to what? 0. Alright, so what will you do here? Let's do our cross multiplication. Or we can first say that the dy ds is the same as 2s negative 3 indices. So when we do cross multiplication, we get dy is equal to 2s to the power negative 3 ds. So now we can integrate both sides. And this you get y, and this 1, 2. When you integrate this, you have to be careful in the integration here. Here, we know that this one will affect this, multiplying by s of this ds. And here you get y is equal to, this is 1 over 2 raised to the power 3. Then the integral of x to the power negative 3 what? Yes. Hope you are following. So when you do that, you're going to get y to be equal to 1 over 8, and the integral of that, when you add 1 to this, you get negative 2. Then you divide by what? 2. Okay? Then you divide by what? 2. So that is what you divide by negative 2. So you're going to get y is equal to negative 1 over 16. Then x to the power negative 2 plus c. Negative 1 over 16 x squared plus c. But now this is the general solution. So to apply the IVP, then we put x to be equal to 0, y to be equal to 1. So we get 1 is equal to, here is y. 1 is equal to negative 1 over 16, 0 plus c. You know that here we are going to get, like, seriously. Alright, so here we are going to get c to be equal to what? 1. And when we get c to be equal to 1, then we do the substitution back into the equation. This. So when you do the substitution back, you get y to be equal to, you're going to get y to be equal to negative 1 over 16 x squared plus 1, because the c here is now what? 1. So this is a particular solution, and this is what a general solution. So that is the idea that I want to give to you for that. Alright, we will be back to solve integration by substitution. Until then, see you.